Welcome to Maths with Bob. Today we're looking at the extensions of the complex number work into what's called complex locus. Can you see here I've written a few notes here about basically the idea of complex locus is actually related to complex functions, and we create a new complex function basically from using some values from another complex number. So it's like a mapping from, if you like, one complex number plane to the other complex number plane, but it's really just moving points around in the complex number plane. And basically, if we do, we have to be a little bit careful how we do this, because if I start feeding this function all the values in the complex number plane, I get another complex number plane full of points. But basically, I have some of these things called colorful, the different ways to represent this, but one of them is a colorful map, or a color map, and using hues and saturations and those sorts of things, but like contour lines. And you can see, I'll show you a few different ways they're doing this, but at the end of the day, we need to be careful how we do this. We have to actually constrain our input. Okay, so let's actually have a look at, okay, here we have a nice color map, and you can see here that there's a couple of singularities, but basically it's just, you can see here lots of different colors, hues and saturations of different colors, like a color wheel. If you look at Wolfram Alpha and just have a quick look, you can see here that they do, let's have a quick look up here, but basically just you can see here they do these 3D plots, the real parts plotted, the imaginary parts plotted. They do some sort of contour plots as well in here, and this is in Wolfram Alpha. Okay, so basically there's lots of different ways to do contour complex number function mapping, but what happens in complex numbers is really we just create a new complex number. Basically, I call it big Z, which is like a mapping, if you like, or a complex function really. And you can see here I'm looking at a particular example where the function is actually z squared plus 2z plus 3, and those previous graphs were actually the plots of those. And you can see here, how do we do this? Well, the first thing is, if you like, you obviously look at let z equal x plus iy, that is little z, and you can see it's little x plus little iy. And we basically put that into z squared plus 2z plus 3 and look at the real and imaginary parts. And then we equate that to the new big Z, which is big X plus I big Y. You can see here I've now got big X is equal to x squared minus y squared plus 2x plus 3, and big Y is equal to the imaginary part, which is just 2xy plus 2y. Okay, so far so good. So what do we do now? Well, we now basically need to, if you like, feed this new big complex number, or function, if you like, a particular constraint. Now I'm actually going to feed it a line, which is x plus ki, where k is real. So I'm basically going to let little y, equal k, and just see what happens. So you can see here I've let big X is equal to now little x squared minus k squared plus 2 times little x plus 3, and you can see this follow through here. But what I need to do now is, you can see here I've got little x is equal to big Y over 2k minus 1, and I sub it into big X, and basically I end up getting big X is equal to y squared all over 4k squared plus 2 minus k squared, which is a family of parabolas. Okay, so let's just have a quick look at this. Okay, you can see here I've just used GeoGebra here to do the, if you like, the plotting, and you can see here at the moment I've just got a line, okay, x plus, well, it's k, which is actually 1i. So all these values you can see here are just lying on the line z equals x plus I, if you like. Think of it just 1i. Now if I change, and you can see the resulting mapping is this particular maroon coloured parabola on the side. So if I just change this, you can see here, I'll just change this slightly. You can see here, this is different lines. I'm now, if I just put in, say, feed the line, let's try and feed the line, go up to 2. Here we are, can't really see that too well. But this is now, I'm feeding the, if you like, the function z squared plus 2z plus 3. I'm now feeding it the line, okay, it's x plus 2i. And you can see here the actual constraint forms another parabola, just one of the family of parabolas, obviously, which we just looked at before. Okay, so we can keep on doing this. If I actually put in another line, let's put one down here at minus, say, 2, minus 2. Here we are, here's one at minus 2. Here we have, I'm feeding the line x, okay, minus 2y. So I'm feeding that line into that particular function and creating a locus. Okay, so I'm constraining it just to feed it in one line. Okay, and you can see here it's just a parabola. Okay, well, thank you for watching, and bye for now.